Hi, I'm Mike Hoyer, HBK Applications Engineer, and this is a short video on setting up CAN publishing and CAN recording on a Genesis Power Analyzer. Genesis offers a wide variety of standard integration options for interfacing your automation PC to Genesis with minimal latency for transferring real-time calculated results, recording additional signals, and remotely controlling the Genesis mainframe for automated integration. Now, these interfaces include CAN, EtherCAT, GenDAC API, Python, Perception Remote RPC, XCP over Ethernet, LabVIEW VI, Hardware TTL, PNRF Reader Toolkit, and Perception Custom Software Interfacing CSI. In this video, we're going to focus on the CAN option. The CAN interface option is not available for PC integrated mainframes. However, it is designed for tethered mainframes. The CAN option is available as an integrated option with 4 CAN ports, or you can choose to select the USB to CAN adapter, offering a single CAN port. Now, the integrated CAN option on the Gen 2TB and the Gen 4TB is integrated into the rear of the mainframe. On the Gen 7TA and B and Gen 17TA and B, CAN is integrated into the option card, which takes up an acquisition slot. Now, the first CAN port records CAN signals, outputs CAN signals like calculated results, and offers mainframe remote control. On the integrated option, you can also record CAN signals on ports 2, 3, and 4. On port 1, you can output up to 1,000 live result blocks per second. The output allows you to publish calculated results like RMS voltage, current, power, etc., whatever you decide, and we'll describe how to set that up in a moment. The number of results that can be published per block is based on the mainframe as shown here. The input allows you to record up to 250 CAN signals per port, so with 4 ports, that's 1,000 signals. And the remote control capability includes commands like start, stop, preview, trigger, etc. Well, to set up CAN publishing, you'll need to click on the Settings tab sheet, then click on Publishing in the list, and then click on the button CAN Port Setup. And this will display the mainframe settings window. Now, to set up CAN publishing, we'll need to click on CAN Port 1 in Out Control, and we'll need to uncheck the Listen Only mode so that the output is enabled. Now we'll need to click on the output for port 1 to see the CAN mode, the update rate, and other CAN parameters that can be changed. However, we'll stick with the default shown here. Now, to set up the signals to be published, in this particular example, we're going to select the inverter out current and inverter out voltage by clicking the red X in the Publish to CAN column and changing it to a green check mark. Now, you'll notice that the system will automatically set the CAN message ID and CAN message byte range for each signal. However, you do have the option to manually change it. We're going to stick with the default for this example. Now, next, we'll click on the Save CAN DBC File As button, and a window will pop up to save the DBC file. Now, note that the DBC file needs to be used on the device that will receive the published CAN signals from port 1 on the Genesis, so it knows how the CAN signals are structured. Now, to record CAN signals, we'll use the DBC file we just saved and set up CAN port 3 to record the published signals from port 1. And if all goes as planned, this will be a nice sanity check to make sure that the signals being published are the same as being recorded. So to set up CAN recording, we'll first click on the Sensor Database tab sheet and then click on the dynamic pull-down menu, now titled Sensor Database, and select the item Import CAN Database in User Database. This will display a window to select the DBC file to be imported, as we see here, and we're going to select the DBC file we saved previously. Next, we'll go to the User Sensor Database and look for the imported folder, expand the tree to see the DBC file, and then expand further to display the structure of the DBC file. In fact, here we see it includes the two signals we're going to publish, the inverter out current and the inverter out voltage. So to set up the signals to be recorded, we're first going to click on the Settings tab sheet and then the CAN channel in the list, and then pin the Sensors window and expand the tree of the imported DBC file like we did previously. In fact, we'll now click and drag each signal to one of the CAN channels. Now in this example, we've clicked and dragged the inverter out current to CAN recorder 3 channel 1 and the inverter out voltage to CAN recorder 3 channel 2. Well, now here's a screenshot of the great sanity check. In other words, the same result is seen published as is being recorded. So if we take a look at the bottom left of the screen, we're displaying in the first row of meters indicated by the blue arrow the calculated results that are being published via CAN. And in the second row of meters with the red arrow, these are the calculated results that are being recorded via CAN. So basically, we have a CAN cable running from CAN port 1 to CAN port 3. Now you'll notice that the results for inverter current and voltage are slightly different, indicated by the blue, red, and green arrows, because each numeric display only updates at about 5 times a second at best, and they update asynchronously, whereas results stored as a waveform contain every calculated result. Now take note that in this example, the real-time calculations are updated 114 times per second using the default zero crossing point on the first phase of inverter current, which is the frequency we see on the inverter block in the drivetrain diagram. And there you have it, a quick example on how to publish and record via the CAN bus. More details are available on the Genesis Power Analyzer at the eDrive webpage. You can go to hbm.com/eDrive and you'll see links to the brochure, datasheet, and more. For technical support, you can use the emails listed here. For North America, go to support@usa.hbm.com. Outside of North America, go to support@hbkworld.com.